Okay, so if you are there as usual, they are not on time. Okay, so I will not waste the time of okay, others who are connected on time here. Let us start here. Mm, okay, the first thing that as we discussed here in the last session is your semester. The semester is again roughly exactly of 15 weeks here. So this time also you will not get enough time for PL probably. Okay, maximum 1 week may be given, but I will try to finish my syllabus up to 14th May so that 13th May your final exam will start and so my plan is that before CT1 I will finish numerical method. So CT1 syllabus is numerical. Probably CT1 I will conduct in MCQ base. Okay, so only MCQs will be for CT1, no subjective question paper. Yes, CT2 will be subjective there. Probably again it is open book, but the syllabus for CT2 will be Laplace transform there. Two topics I will finish in last 4 weeks there. Okay, so that about your syllabus. 4 units are there. The first unit, that is numerical method, we started in the last session. Last session we started this bisection method from numerical method, and already I told that each unit will have roughly the 22 to 25 marks weightage in the final exam. So first article we started from that is a fiction. This is a solution of algebraic and transcendental equation. Roughly one question will come in the final exam for 5 marks. So let me see what is a bisection method. Yes, you already completed in the last section, but here okay. Can you tell me what is the formula of a bisection method that we seen?
A plus B by 2.
Yes, correct. A plus B upon 2. That is the simple formula we have for bisection method. But we'll start with this part. Actually, all these methods are to solve the equation fx equal to 0. Okay. So we have some function of x. Right? So this function of x may be algebraic. Algebraic means only the algebraic terms are there. It's a polynomial in x. Or it may be a transcendental equation which involves trigonometric, exponential, or logarithmic term. So our aim is to solve this equation. Our aim is to get the root of this equation. To get the root of equation, there is a first important condition is, yes, anyone? What is that condition so that we get the root in that root of that equation? What is a condition that we have for x?
Should be less than 0, should be more than.
Okay, so partially true. It is not necessary f of a only less than 0. We should say f of a and f of b should have a opposite sign. Okay, suppose f of a is a positive. Right now I take this point as f of a. Then f of b I will take somewhere. Okay, assume this is our f of b. Then this is if this is f of a and if this is f of b, so obviously this point is x equal to a and this point is x equal to b. So indirectly we are selecting the 2 points a, b, where f of a and f of b have the opposite sign. F of a and f of b have the opposite sign. So the graph, okay, the graph of this function will go like this. Suppose this is the graph I drawn. So then there will be exactly 1 point. There will be exactly 1 point on the graph where this function cuts here. So it is a root, that is x star. So the condition that f of a and f of b have the opposite sign fulfills that as fx is continuous, that curve will intersect to the x-axis at least in 1 point, and that root we have to find out. are
Recording in
generally
progress.
0 to 5. 0, in between 0 to 5, always you get actually one root of the function for a higher polynomial, higher degree polynomial. We select two nearest integer where f of a and f of the opposite sign, and then we start with iteration. Say we take x1 as a plus b upon 2, and we check the sign of f of x1. If this x1, suppose this f of x1 is greater than 0, already f of a is also greater than 0. Now f of x1 is greater than 0. So the next interval that we select, replace a by x1. A by x1. Now the root interval a comma b. Why comma b? Because f of x1 is positive, f of b is a negative. As we have two closer points who have the opposite sign, the root will exist in this interval. Then we'll calculate x2. To calculate x2, we use this x1 plus b upon 2 now. Whatever this new x1, this is acts like a now here. And then we
Recording in progress.
should be replaced from x1 and b, which should be replaced.
B.
Yes, B, correct. This is the correct answer because f of b is negative, f of x2 is negative. So the new root will be in the smaller interval, which is x1 comma x2. And from this interval, we can get x3 as say x1 plus x2 upon 2. So, and we proceed this logic to get the better approximation of the root. Remember, all the roots are approximate root. They are not exact root. They are accurate up to certain decimals, or sometimes the stopping criteria is number of it. So the question comes into, we'll discuss that. We'll discuss it one by one in false position method now. Okay. Any doubt here?
No, sir.
No. So let me start a new method here. Now the bisection, false position method. Okay, the next method that we have is the false position method, or you can use. Okay. Ages, you don't have a control on your mic here, huh?
He's next to my room.
Recording in progress.
So to the second method, the method is a method of by root exists. Here in false position method, we again start with two nearest integers where the function have the point. Now let we assume this is a. This point is a. Just 1 minute, I will take. So this is the point A. This is f of a. Is it positive or negative?
Positive.
Is it positive? F of a is a positive. Say this is B now. If this is B, this f of b is negative. Okay. One negative, this ensures the roots between the interval AB. Step number 1, interval AB where the root exists. Now, instead of taking x1 as a plus b upon 2, what we are going to do it, we need to draw a chord AB. So just join the point a comma f of a and b comma f of b by a straight line. If you draw that line, this line will intersect at one point, and that point we taken as x1. Let me assume this point is x1 now. This is our first iteration. So x1 becomes a f of b minus b f of a upon f of b minus f of a. Now, how this equation comes? This equation comes by 2-point formula of a straight line. So just we find out the detail. So that way we can derive this formula. The derivation will not come in the exam. Just you have to remember, this is the formula of false position method. Now, once at x1, f of x1 in this case is less than 0. As f of x1 is less than and f of a is greater than, the root exists in the x. Direct replace b x1 because b is negative, f of x1 is also negative, so a comma x1. And now again draw other root x2, we got x2, that f of x2 is again less than 0, so the it continues a comma x2 and so on. So start with b, then we come to the x1, we come to the x2, and now it this exact root. Actually this is the this point is actually the true root. Okay, so this x star is a true root, and that is after certain iteration going closer and closer to the true root, and we'll get exactly the correct root. But that you have to remember, formula of bisection method and formula of a false position method. So that is the most formula. No. Okay. This is very simple method now. Already you know this thing. So the question is find the root of this cube position between this interval is again given. So the interval is 2, 3. These are the two nearest integer where the we have to cross check at the beginning. So whenever any example is solved by bisect position method, one, just check with that f of a and f of b have the opposite sign. If they have opposite sign, only you should proceed. So when we start a solution, so given fx is x cube minus 2x plus 5. So anyone, what is the value of f of 2? What is f of 2? F of 2 is a -1, it's a negative. So f of, is it positive? F of 3? Yes, what is the value? The 2 is a negative, f of 3 is positive, so the root is in the interval 2, 3. So that is the first statement you should make when we solve these questions. There is one small difference between bisection and false position. That difference is, in bisection method, we just focus on the sign only, negative and positive, not interested in their magnitude, what that number is there. So in bisection, we say f of 2 is negative, f of 3 is positive. We don't say it is a -116, not required actually. Even though you write, it doesn't matter. But in false position, these values are important because they are used in calculation. They are used in the iteration formula. Okay, so if we come to the solution of bisection, this false position now, you will observe, sorry. If you see the solution now, you will observe n represent the number of iteration. Yes, we already know it. So that's the iteration we have. So then a and b, f of a, f of b will start at n equal to 1. It is given 2 and 3. We'll observe f of a is a -1, f of 3 is 16. So root exists there. So x1 we calculated with this one. This is a into f of b, 2 into 16 minus 3 into -1 divided by 16 plus 1, that is 17. If you do this calculation on calculator, you'll get the first iteration or the first approximate root of that cubic polynomial. So this is x1. Now we calculate f of x1. Just replace this number in that fx, this fx. So when you replace in fx this x1, you get f of x1 is negative. So which number should be replaced here? If f of x1 is negative, should we replace a or b? X1 should be a or b? Yes.
A.
It is a. A is the correct answer. Correct. Here you will observe this x1. This x1 is written here only. So it is written in the position of a there. Why it is written in the position of a? Because f of a is a negative as well as f of x1 is also negative. So a is replaced by x1. Now the root exists between this x1 and b. With the help of this x1 and b, we calculate x2. We proceed with the same logic. Generally, in the regular falsification method, you will converge from one side. Right now, you will observe every time a is changed. Okay, a is changed. But in bisection method, that you may have any criteria. It may possible you will or sometimes you have to replace a, sometimes b, that way. We'll not go in the detail there. Just simply the same logic you have to continue. And here 7 iterations done. Why only 7 iterations done? Anyone? Any idea? Why the 7 iterations I completed only here? Why not 5? Why not 3? Why not 10?
The value was repeating, like 2.094 was coming constant.
Yes, very good observation. It's a very, very good observation. That is a very important thing that you should notice here. You should have a good observation in maths. That will, by observation only, you can learn many things here. So the most important thing that you will observe that the numbers start repeating after a certain thing. You will observe in this 6th and 7th iteration. You will observe in 6th iteration and 7th iteration. Mainly the first 3 decimal 0.094, 0.094 start repeating. They become same. Okay, that not happened previously anywhere. So you'll observe here is 0.093, 0.091, 0.088. So that way. So as the last 3 decimals are repeating, this answer is correct up to 3 decimal places. And why we only focus on 3 decimal? Because they given that given in the question. It's given in the question. We want the answer correct up to 3 decimal places. So again, it is approximately correct up to 3 decimal places. So the correct root is, the root of this equation is 2.094 after the 7th iteration. Is that clear?
Yes, sir.
So there are 2 conditions to stop the iteration. One condition is like this: correct up to the decimal places. That time when the decimal places start repeating, you have to stop the iteration. Or in the question only it is written, do the 7 stages. If it is written 7 stages or 7 iteration, okay. If it is written do the 7 stages or 7 iteration, then you have to do that 7 n equal to 7, up to n equal to 7 you have to do it. So that way also you have to do the iteration, or you have to stop the iteration mainly. Okay, so that about false position, nothing different actually than the bisect. Only formulas are different. Mainly logic goes same. Their iteration formulas are different. So we'll take a next question here. Now, next question is here on the screen. You will observe our aim is to get the root of this equation, x e raised to x equal to cos x. Can anyone tell me any special thing about this equation? What is this equation? Which type of this equation? Hello. Which type of this equation? What is the name of this equation? We are solving 2t. Yes, transcendental. This is the transcendental equation because it involves exponential and trigonometric terms. So that is the one thing. Now, this is not given in the form of fx equal to 0. So few students can take fx as, there are 2 ways. You can take fx as x e raised to x minus cos x. So this one is your fx. Actually, fx equal to 0 is solving. So you can write equal to 0 also. So this is your fx, or if some of you are not interested to take cos x on the left side, you can take x e raised to x on the right side. So both are your fx. At the end, if you find out the root of this equation, or root of this equation, your answer is the same. Your answer is same there. Okay, you should not worry. Actually, I done the calculation with this second fx. Okay, I done the calculation with this fx cos x minus x e raised to x. Choice is your. You can do with this also, and you notice your answer will be the same there. Only if I take this fx and my f of a is suppose positive, then in that case, in this fx, f of a is negative. That will be the change. Another important thing that you will notice here is interval is not given. Interval is not given. Can you tell me what is the interval? Yes. What is the interval that you will notice here? Yes, anyone? As no interval is not given, how to get that interval? How to get the interval? Yes.
Interval 0 to 1.
0 to 1. Good. So actually, the method to get the interval AB is hit and trial method. Hit and trial method. You have to just start with f of 0, f of 1, f of 2, f of 3, and you have to find out two nearest integer where that fx changes its sign. Let I show you here. So for a solution, first thing you will notice this question takes a trigonometric function. So whenever the trigonometric function appears in any of the example, all the calculation you have to do it in a radian mode of a calculator. Don't forget to change the mode of a calculator as a radian mode whenever the trigonometric function occurs. Otherwise, your entire calculation becomes wrong. You will not get a correct root there. Remember. Okay. So whenever trigonometric function appears, mode of to change the mode of calculator, is it? So the fx is I taken cos x minus x e raised to x. Okay, already I told you can take x e raised to x minus cos x also. So can you tell me what is the value of f of 0 then? Then let's start with 0 for hit and trial method. So just calculate f of 0. Quick. Use the calculator, use the radian mode. What is f of 0? It's so simple now. Without calculator also you can tell me.
Sir, 1.
1. Yes, correct. F of 0 is 1. F of 0 is 1 means it is greater than 0. It's a positive. Okay. Now calculate f of 1 now. Tell me the answer. F of 1. Just 1, 2, 4.
Minus.
It is 0.50 minus e raised to 1. How to get e raised to 1? Just press shift button on calculator. Press ln tab. So you get e and just press 1. E1. Don't press arrow button here. Don't press arrow. So e raised to 1, e and 1 directly press. The final number you will get f of 1 as
minus 1.
Is it minus 2.17798? Are you getting this answer? If not, then you made a mistake. Okay, if you're getting another you probably you're not in radian mode or you are not able to get e raised to 1 properly. I will tell you how to get e raised to 1. Press shift, press ln tab, you get e and just press number 1, e1. E1 is 2.71. You know that is standard number. Value of E is 2.71. And that only you will get it. Okay. Anyone have the problem in getting f of 0 and f of 1 here? No. The most important thing you can observe here that f of 0 and f of 1 have this opposite sign. F of 0 is positive. F of 1 is negative. So this is the important thing we should have. So as 0 and 1, they are opposite, we can say the root lies between 0 and 1. So first we decided the interval here as that is not given in the question. Got it? So the answer then. Now this is the table that you have to prepare like previous. The remaining part is not new. Already we discussed these things. So we start with first iteration, say n equal to 1. 0 and 1 are the values we decided. F of A and F of B is written here. X1 is calculated with this formula, A F of B minus B F of A upon F of B minus F of A. What happened here? F of X1 is positive or negative?
Positive.
Positive. F of X1 is positive. So, and F of A is positive. Again, A is replaced by X1. A is replaced by X1 because F of A and F of X1 are positive. And every time the A is replaced here and the root lies between this interval. And again, we done 8 iteration. Why the 8 iteration only done? The same logic is there. We want to correct up to 3 decimal places. I again tell you, I will remove from the meeting. Reno. Okay, I will remove him. He is not able to control his mic. This is the second, third time happened with him. Okay. So that about the method. Any doubt here?
No, sir.
No doubt. Okay, good. So this one is the way you get regular false method on small change with I will show you one more here, last question, but I will not show you a complete solution. Do it is because it is assignment question. This is the example from the first assignment or the first tutorial, which I shared with you on the WhatsApp group. The question is use a method of false position to find the 4th root of 32. Correct up to 3 decimal places. The equation is not given. Can anyone tell me what equation we should take it so that we get the 4th root of 32? Yes. What should be the equation? Yes, quick. No idea. What should be the equation for getting the 4th root of 32? No one is able to create equation. Huh? Is it so difficult? Which value we want?
X raised to the power 4 is equals to 32.
Okay, good, very good. That's a correct answer. So first, actually, we want 32 raised to 1 by 4. So we'll assume we want actually X, which is nothing but 32 raised to 1 by 4. So if you take fourth power on both sides, X4 equal to 32. So our Fx should be X4 minus 32. Okay, so this is the equation you should use. Now, you can start with, again, you can hit and trial, you can directly start with X4 or 4, but by hit and trial method, if you see F of 0 is minus 32. Okay, F of 1 is a minus 31. F of 2 is a minus 16. F of 3 is a 49. And this is the good thing that we can observe, that Fx start changing its sign on 2 nearest integer. F of 2 is a negative while F of 3 is a positive. So we can say the root is in the interval 2, 3. And then we can start that formula of iteration and we can get the approximate root correct up to the 3 decimals. So this just changed to solve that question. Okay. Remember your tutorial that you have to submit on or before 23rd. Tomorrow morning you will be on TMI LMS. Okay, on TMI LMS. That is 22, and on 23rd you should submit this tutorial. Remember, already I told these tutorial submissions are very important for the sake of the internal marks as well as your understanding of the subject, because don't think that your final exam will be of the same pattern like online exam in the last semester. IMU can change the exam pattern at any time. They take your offline exam. You should ready for each and everything. Okay. Last year, suddenly they changed to the MCQ. Okay. And a few students confused also. They should not. Okay, that's for today.
So in tutorial one, the bisection question A and B is not given. So should I use the hit and
Yes, yes,
method?
obviously. Everywhere, whenever the interval is not given, you have to go for hit and trial method. Yes, who is the CR from the last batch? Is there anyone? Last semester's here.
Yes,
Any absentee today?
sir, 1 minute.
Yeah, okay. Because due to first, where is Reno? He is troubling today. Just